Decades of research and debate, the Shroud of Turin, that's a piece of history, and it has an ongoing puzzle for some.
For centuries, the Shroud of Turin has stood at the crossroads of faith and doubt. To millions, it is believed to be the burial cloth of Jesus Christ, bearing the silent imprint of a crucified man and standing as the only physical remnant tied to the resurrection. To others, it is something else entirely, an elaborate deception, a masterwork of medieval artistry designed to satisfy a world desperate for miracles. But the 21st century changed the rules. Philosophical debate gave way to forensic scrutiny. Speculation was replaced by instrumentation. The shroud was no longer treated as a sacred symbol or a relic behind glass. It became evidence. Scientists approached it the way investigators approach an unsolved crime, methodically, relentlessly, and without reverence. What they found inside the ancient linen stunned them. Embedded deep within the fibers were biological traces, DNA fragments preserved across centuries. When researchers began extracting and sequencing this genetic material, expectations were modest. They anticipated contamination, perhaps residue from a single individual, maybe even pigments consistent with medieval techniques. Instead, the data defied every assumption. Teams working with advanced genetic analyzers and high-precision imaging technologies discovered patterns so complex that they dismantled both sides of the debate at once. Traditional religious explanations could not fully account for them. Skeptical theories collapsed just as quickly. The results didn't merely challenge existing interpretations, they erased them. The shroud ceased to be cloth. It became a record, a biological archive tracing a journey that began 2,000 years ago. A forensic map of suffering rendered with such precision that modern science cannot reproduce it. Even more unsettling, physical analyses pointed toward a short, intense burst of energy, an event powerful enough to form the image without heat, paint, or contact. The mechanism behind it remains unknown to modern physics. This discovery marked the beginning of the most comprehensive investigation ever conducted on a single artifact. Researchers followed trails invisible to the naked eye. Microscopic pollen grains lodged between threads. Molecular residues locked in bloodstains. Biological markers preserved like fingerprints in time. Each clue narrowed the field. Each result raised new questions. Whose blood was this? Why does its chemical structure reflect extreme trauma? And why does the image encode information in ways no artist could have intended? The image itself posed another mystery. It behaves like a photographic negative, revealing detail only when inverted. It carries three-dimensional depth information, functioning almost like a hologram. Certain characteristics resemble X-ray imaging centuries before X-rays existed. Then came the finding that stunned researchers most of all. Genetic evidence suggested the artifact could not have originated in medieval Europe. The biological signatures pointed elsewhere, toward a geographical and historical context that aligned with events capable of altering the course of human history. To understand how revolutionary these conclusions are, we must return to the moment when modern science first truly encountered the face hidden within the linen. That moment came on May 28, 1898, during a public exhibition in Turin held to commemorate a royal wedding. An Italian lawyer and amateur photographer, Secondo Pia, received rare permission to photograph the shroud. At the time, photography was a demanding, fragile process. Pia erected scaffolding inside the cathedral, hauled equipment the size of a suitcase, and relied on harsh magnesium flashes to illuminate the dim interior. He exposed two large glass photographic plates. Later that night, alone in his darkroom, Pia immersed one of the plates into developing chemicals under the faint glow of a red lamp. As the image slowly appeared, he froze. What emerged was impossible. On the photographic negative, where light should invert and shadows should dominate, there appeared a sharply defined, high-contrast positive image. Not a vague outline, not a stain, but a man. A face with closed eyes, a fractured nose, a mustache and forked beard, bruising along the cheek. Calm and authority etched into features shaped by brutal suffering. For the first time, the figure within the shroud stepped out of abstraction. It was no longer a shadow. It was unmistakably human. The effect was immediate and irreversible. What emerged was not merely surprise, but a fundamental shift in how the shroud could be understood. Until that moment, skepticism had rested on a simple assumption that the image behaved like any other human-made representation. That assumption collapsed instantly. A conventional drawing, whether formed with pigment, charcoal, or even blood, responds predictably when converted into a photographic negative. Light reverses to dark. Dark becomes light. The result is distorted and artificial, producing a flat, mask-like inversion that strips the image of realism. The shroud does the opposite. When photographed as a negative, it transforms into something eerily familiar, a lifelike black and white portrait of a real human being. Depth emerges, facial structure becomes clear, proportions align naturally. What appears faint and ghost-like to the naked eye resolves into clarity only when reversed. That single fact shattered centuries of assumptions and has never been successfully explained away. What we see on the cloth in normal light is not a positive image at all. It is already a negative. That realization raises a question with no comfortable answer. Who, in the Middle Ages, understood the physics of light reversal? Who possessed knowledge of photographic principles centuries before photography existed? And how could anyone intentionally create a perfect negative image without any method to preview or confirm the result? There is no historical candidate. Photography would not emerge for nearly 800 years. More critically, the human visual system is not biologically capable of perceiving the world in negative, much less reproducing it with such subtle gradations of brightness and shadow. No artist, no matter how skilled, could have done this deliberately. This was the first real fracture in the wall of skepticism. The shroud did not behave like art. It behaved like an exposure, like a photographic surface that captured a single instant in time. As decades passed, the cloth was subjected to every non-destructive technique modern science could offer. X-rays, ultraviolet fluorescence, infrared imaging, laser scanning. Each method revealed new layers of complexity. Yet the most profound evidence was not found in the image itself. It was found in the dust. Trapped within the microscopic spaces between linen fibers were particles accumulated over centuries, pollen grains, mineral fragments, organic residues, sealed away by time. These tiny witnesses carried a record far older than any visible stain. In 2015, a multidisciplinary team of geneticists and biologists at the University of Padua was granted unprecedented access to these materials. Their objective was not sensational, but quietly radical: to locate and analyze DNA preserved within the cloth. They were not searching for the DNA of God. Science has no framework for such a concept. There is no control sample, no theoretical baseline. Instead, the researchers sought to reconstruct the life history of the shroud itself, where it had traveled, who had touched it, and how it had moved through human hands over centuries. To accomplish this, they employed specially designed sterile microvacuum devices equipped with ultrafine filters. These instruments gently extracted microscopic material not only from the surface, but from deep within the weave, areas where ancient biological traces can remain protected for thousands of years. They also analyzed particles collected during the 1988 restoration, samples that had been meticulously archived under controlled conditions. The margin for error was razor thin. Even the slightest modern contamination, a breath, a sneeze, a fragment of skin, could overwrite ancient genetic signals with modern noise. For this reason, the samples were transferred to ultra-clean, high-grade laboratories. There, sequencing began using next-generation sequencing technology. The team focused on mitochondrial DNA from both humans and plants for a critical reason. Unlike nuclear DNA, mitochondrial DNA exists in hundreds of copies per cell, is inherited exclusively through the maternal line, and survives far longer in ancient material. It serves as one of the most reliable markers for tracing geographic origin and human migration. For weeks, computers ran continuously, decoding millions of nucleotide sequences and comparing them against global genomic databases representing populations across continents. When the final visualizations appeared, maps of haplogroups and ancestral lineages, The researchers understood immediately that they were facing something unprecedented. This was not the genetic signature of a single person. It was a genetic cross-section of humanity. The results were published in Nature Scientific Reports, and the response was swift and intense. The findings sent shockwaves through the scientific community because they defied every simple explanation. If the shroud were a medieval forgery created in France, European DNA should have dominated the results. If it were an untouched relic from Jerusalem, genetic markers should have pointed almost exclusively to the Middle East. Neither scenario matched the data. What appeared instead was a convergence of lineages from across Eurasia and Africa, encoded into a single piece of linen. Middle Eastern haplogroups emerged first, including markers associated with the Druze, a historically isolated ethno-religious community in the Levant, whose genetic stability over millennia makes it a powerful geographic indicator. Western European haplogroups followed, entirely consistent with centuries of handling in France and Italy by clergy, nobility, and pilgrims. Then came the unexpected. North and East African markers appeared, pointing toward regions such as Egypt and Ethiopia, home to some of the earliest Christian traditions. South Asian haplogroups followed, characteristic of the Indian subcontinent. Finally, genetic signatures associated with East Asia, including markers linked to China, entered the dataset. Africa, India, China, Europe, the Middle East, all present, all real. This was not medieval Europe, and it was not a closed regional artifact. The question became unavoidable. How could a cloth allegedly forged in a European monastery in the 14th century carry genetic traces from across the ancient world, centuries before globalization existed? The answer, when it emerged, was even more unsettling than the mystery itself. The shroud was not merely a burial cloth, it was a traveler. When scientists mapped the genetic distribution spatially, they noticed something extraordinary. The data aligned with remarkable geographic precision along an ancient historical route, one that many scholars had long dismissed as legend rather than reality. The journey of the image had left a trail. Early Byzantine, Syrian, and Arabic accounts describe the shroud in a form very different from how it appears today. According to these sources, the cloth was folded lengthwise and then again, leaving only the face visible. This configuration, known as the tetradiplon, was mounted within a rigid frame and displayed as a sacred image. What most people overlook is this crucial fact. During this period, the relic was not in Europe at all. Its journey began in Jerusalem, the city of execution and burial. From there, it disappeared from public view and re-emerged in the 2nd century in Edessa, modern-day Şanlıurfa in Turkey. For generations, the cloth was concealed within the city walls, regarded as a protective presence rather than an object of spectacle. When it was finally revealed, Edessa was no minor outpost. It stood at one of the most important crossroads of the ancient world, the Silk Road. Merchants from China and India passed through its gates. Traders from Persia and Arabia exchanged goods there. Pilgrims, emissaries, and travelers from across Eurasia came to venerate the image believed to safeguard the city. They stood close to it. They touched its casing. They kissed the frame, and with every encounter, microscopic traces, skin cells, hair fragments, sweat settled invisibly onto the cloth. Century after century, these traces accumulated. What modern genetics later identified as global DNA was not planted. It was deposited naturally, layer by layer, through human contact as the relic moved across civilizations. The journey did not end in Edessa. In 944, the shroud was transferred to Constantinople, the heart of the Byzantine Empire, where it remained for nearly 3 centuries. At the time, Constantinople was the greatest city on earth, a true imperial crossroads where cultures, ethnicities, and peoples from every corner of the known world converged. The relic was housed among the empire's most sacred treasures and exposed to a population unlike any other in the medieval world. Then came catastrophe. In 1204, during the Fourth Crusade, Constantinople was violently sacked. Churches were looted, relics vanished. In the chaos that followed, the shroud disappeared from Byzantine records altogether. Within a year, it surfaced in Athens, now under the control of French crusaders. From there, its path led westward, By 1353, the cloth appeared in France in the possession of the knight Geoffroy de Charny. This marks its first undisputed appearance in Western Europe, and this is precisely where the medieval forgery theory collapses. A forger working in 14th or 15th century France could not possibly have gathered biological material from people originating in China, India, the Middle East, and Africa, regions he knew only through rumor and rare travel accounts. Even more implausible, he could not have deliberately distributed that material across the fabric in a way that would withstand genetic analysis 6 centuries later. The DNA found on the shroud is not random contamination, it is cumulative history, a biological archive formed by countless individuals who encountered the same object over extraordinary distances and time. It represents the memory of human contact itself. And DNA tells only half the story. The other half is botanical. Pollen analysis, palynology, provided an independent line of evidence. 2 experts approached the problem separately: Avinoam Danon, a leading Israeli botanist, and Max Frey, a Swiss forensic scientist renowned for his work in pollen identification. Using adhesive sampling methods, they extracted microscopic pollen grains trapped deep within the linen's weave. What they discovered astonished the scientific community. 58 distinct plant species were identified. 17 were European, exactly what one would expect given the shroud's documented presence in France and Italy over the past 6 centuries. But the majority were not European at all. They originated in the Middle East, Anatolia, and regions precisely aligned with the relic's ancient eastern route through Edessa and Constantinople. Then came the most compelling result. Several pollen species identified on the cloth grow nowhere else on Earth except within a narrow corridor between Jerusalem and Jericho. One plant dominated the samples, Gundelia tournefortii, a thorny desert thistle. Its pollen accounted for nearly half of all pollen recovered from the fabric, an extraordinarily high concentration. This raised a critical question. Why would a burial cloth contain such an abundance of pollen from a thorn-bearing plant? The answer emerged when historians returned to the Passion narratives. Roman soldiers mocking a condemned man as king of the Jews. On a crown twisted not from metal, but from thorns, Gundelia tournefortii, with its long, rigid, needle-like spines, is exactly the type of plant such a crown would require. Even more striking, this plant blooms around Jerusalem in early spring, during Passover. The pollen was most concentrated around the head and shoulder regions of the cloth. The pollen was no longer silent, it was testifying. Additional confirmation came from Zygophyllum dumosum, a plant native only to the Judean desert in parts of the Sinai. Its pollen was also present in significant quantities. No medieval artist in France could have sourced such material, let alone applied it invisibly at a microscopic scale. Pollen cannot be painted, it acts as a geographic fingerprint, one that cannot be forged. For decades, skeptics argued that the reddish stains on the shroud were pigments, ochre, cinnabar, or tempera. That argument collapsed in 2017. A team of Italian researchers led by Giulio Fanti, working alongside medical specialists, examined the stains using transmission electron microscopy and Raman spectroscopy at the nanoscale. The truth became unmistakable. This was not paint, it was human blood, type AB, one of the rarest blood groups. Even more significant, the blood contained nanoparticles of creatinine and ferritin bound to hemoglobin. Such concentrations occur only under extreme physiological stress, prolonged torture, massive muscle damage, dehydration, and organ failure. The biochemical signature was unmistakable. This was the blood of a man who suffered catastrophic trauma before death. Repeated blows caused muscle breakdown, rhabdomyolysis, flooding the bloodstream with creatinine. The blood chemistry recorded a body pushed beyond survival, even before crucifixion began. This aligns precisely with Roman scourging practices using leather whips embedded with metal weights. The shroud records evidence of over 100 strikes. No artist could fabricate the molecular consequences of such violence. Pain can be painted. Biochemistry cannot. One final anomaly remained, the color of the blood. Ancient blood normally darkens over time, yet the stains on the shroud remain red. Analysis revealed why exceptionally high levels of bilirubin, released during severe trauma and liver stress. Bilirubin preserves blood's red coloration for centuries. This is not symbolism, it is chemistry under extreme human suffering. At this stage, many ask the same question: what about radiocarbon dating? In 1980, tests conducted by laboratories in Oxford, Zurich, and Arizona dated the cloth to the medieval period. The conclusions seemed decisive. The world moved on. Even the church softened its position. But science does not stand still, and the shroud was not finished speaking. Years later, investigators uncovered where everything had gone wrong. The failure was not technological. It was human. In 1980, radiocarbon testing relied on a single, tiny sample, no larger than a postage stamp, cut from the outer edge of the shroud. That location proved fatal to the conclusions drawn from it. The edge had been handled repeatedly for centuries, grasped during public exhibitions by clergy and pilgrims alike. Sweat, skin oils, candle smoke, bacteria, and environmental debris had accumulated there far more than anywhere else on the cloth. That alone should have raised concern. But the deeper problem was revealed by chemist Ray Rogers, whose later analysis exposed something far more serious. The sampled corner had undergone medieval repair, executed with extraordinary skill and never documented. The material tested in 1908 was not representative of the shroud itself. Medieval restorers had reinforced the damaged edge by weaving in cotton threads dyed to mimic the appearance of aged linen. This was not modern invisible mending. It was a concealed structural repair. Chemical examination of the 1988 sample later confirmed the presence of cotton fibers, plant gums, and dye compounds. The main body of the shroud contains none of these elements. It is pure linen. In effect, the laboratories dated the patch. They measured medieval cotton, dye, and centuries of surface contamination, not the original cloth. This was not a minor technical oversight. It violated a fundamental principle of archaeological science: never date the most repaired and contaminated portion of an artifact. The confidence of 1980 unraveled, recognizing the limits of radiocarbon dating on a heavily handled relic. Researchers sought a method that could bypass contamination altogether, one that examined the fabric itself, not what had settled upon it. That breakthrough came in 2022. Italian physicist Liberato De Caro introduced a radically different approach using wide-angle X-ray scattering, known as DOUS. Unlike carbon dating, this technique does not analyze organic residue. It measures the aging of cellulose within the linen fibers at the atomic level. Linen ages predictably. Over time, its cellulose polymer chains slowly degrade under environmental exposure. Radiation, humidity, temperature fluctuations. This structural decay functions as an internal clock embedded within the material itself. De Caro compared the shroud's cellulose structure with linen samples whose ages are firmly established, ranging from Egyptian mummy wrappings dated to 3000 BC to medieval textiles from the 10th through 14th centuries. The result was unambiguous. The shroud's molecular aging curve did not align with medieval fabrics at all. Instead, it matched almost perfectly linen recovered from Masada in Israel. That fortress fell in 74 AD. The textiles found there are dated between 50 and 74 AD. The implication was unavoidable at the atomic level. The shroud's linen belongs to the 1st century. In 1908, scientists appeared to close the case. In 2022, science reopened it with better tools. Yet one question still refused to yield. How did the image form? There are no brushstrokes, no pigments, no ink. The image exists only on the topmost surface of the fibers, approximately 200 nanometers deep, hundreds of times thinner than a human hair. Scrape the surface, and the image disappears. It is not embedded, it is not absorbed. It is a chemical alteration caused by oxidation and dehydration, a scorch without heat. Researchers attempted every known replication method. Acids failed, heat failed, radiation failed. Only one process produced comparable results: a brief, intense pulse of vacuum ultraviolet radiation. Such technology does not exist in nature and did not exist in antiquity. To imprint an image across the full surface of the cloth, the body would have had to emit an extraordinary burst of energy lasting less than a billionth of a second, powerful enough to alter linen fibers, yet precise enough not to burn or destroy them. In 1976, image analysis using NASA-developed software revealed something even more unsettling. The shroud encodes accurate three-dimensional information. The intensity of the image corresponds exactly to the distance between the body and the cloth. No painting, photograph, or an engraving, ancient or modern, can do this. Further digital enhancement identified faint impressions consistent with coins placed over the eyes, matching rare coins minted under Pontius Pilate around 29 AD. The probability of a medieval artist knowing this detail, let alone encoding it invisibly, approaches zero. Add to this the dust from Jerusalem, pollen from plants that bloom only in the region during spring, blood chemistry consistent with extreme torture, nails piercing the wrists rather than the palms, and nerve reflexes visible in the thumbs. Discipline by discipline, the evidence converges: biology, chemistry, physics, geology, history, numismatics, all pointing to Jerusalem. Between 30 and 30 AD, the shroud defies simple explanation. It is not a painting, it is not an icon. It is a forensic imprint of a real human being, an unrepeatable physical record of a moment that altered history. Returned to its vault. The cloth remains silent, but the data does not. Perhaps one day science will fully explain the mechanism that formed this image. Or perhaps some questions are meant not to be closed, but contemplated. Does science eventually explain every mystery? Or are some doors intentionally left open to reason and to the human heart?